Our topic for today focuses on geological structures. Geological structure refer to the rock features and arrangement in the Earth's crust formed by geological processes. Important purposes of studying geological structure. First, understanding Earth's history and processes. Second, exploration and management of natural resources. And third, prediction, assessment, and management of natural hazards.
Now, let's tackle about the forces that shape geological structures. Tectonic forces are stresses from the movement of Earth's tectonic plates that shape the crust and cause geological features. There are three types of stress, which are compressional stress, tensional stress, and shear stress. First, the compressional stress is a stress that pushes rock layers together, causing them to fold, buckle, or thrust upward. Then, the tensional stress involves forces pulling in opposite directions, which results in strain that stretches and thins rock. Lastly, the shear stress occurs when rocks are subjected to forces that cause them to slide past each other in opposite directions.
There are different types of geological structure. There are folds, faults, joints, and veins. First type of geological structure is the folds. Folds are warps and bends in rock layers caused by compressional forces. There are primary type of a fold. First is syncline. It is formed when rock layers are pushed downward, creating a through-like structure. Another type of a fold is the anticline. It is formed when rock layers are pushed upward, creating an arc-like structure. One classic example of folds is the Himalayas. It is formed as a result of the collision between the Indian plate and Eurasian plate. Let's talk about folds. Folds are fractures in rock where significant displacement has occurred due to stress. There are different types of folds. We have the normal fold. It is due to extensional forces that pull the crust apart. This is where the hanging wall moves down. Another type of fault is the reversed or thrust fault. It is due to compressional forces that push the crust together. The last type of fault is the strike-slip fault, where horizontal shearing causes rocks to slide past each other. One classic example of fault is the San Andreas Fault in California, USA, a well-known strike-slip fault. It is studied due to its role in causing significant earthquakes.
Now let's proceed to joints. Joints are brittle fractures in rock where there is little to no displacement, formed due to cooling or release of pressure in the rock, and the type of joints based on genesis. First is the tensional joints, formed when rocks experience tensile stress that causes them to be pulled apart. Next is the shear joints, formed by shearing stresses that cause one part of the rock to slide past another. Then, the compression joints, formed when rocks are subjected to compressive stress which pushes them together. The veins. Veins are mineral deposits that fill cracks or fractures in rock, formed when mineral-rich fluids move through fractures in rocks and then cool and crystallize. The hydrothermal veins, formed by hot, mineral-rich fluids that travel through fractures in the rock, typically coming from geothermal or magmatic sources. These veins can be significant in resource exploration as they often contain valuable minerals. In summary, folds, faults, joints, and veins each illustrate how geological processes shape and alter Earth's crust. By studying these structures, geologists can gain insights into tectonic forces, anticipate natural events, and locate valuable resources. The influence of geological structures today are the following. First, guides resilient construction to withstand geological hazards. optimizes the extraction and use of natural resources, supports efforts to protect ecosystems and manage natural hazards, improves prediction and response strategies for natural disasters, and lastly, advances understanding of past climates to predict future trends.
That's all for geological structure. Thank you for watching.